I'm Mike, and in this video I'm going to talk about the resonating harmonic drone, what it does, how it works, and why I made it, along with a few demonstrations. And there are chapters in the video timeline if you want to skip around. To give a brief rundown, the resonator works just like a reverb. It takes an amplified input signal which vibrates the strings, and those vibrations are detected by the pickups on the other end. The way the strings respond to the input depends on a lot of factors and allows the resonator to be used in a variety of ways. Broadly, they fall into a spectrum on one end where the resonator is used as an instrument in its own right. In the middle, it behaves more like an accompaniment to another instrument. And on the far other end, it's used more like a reverb in the recording process. About 13 years ago, I was messing around with a spring reverb prototype in the shed, and I thought, what would happen if I swapped out the spring for a guitar string? This prototype actually worked for about 10 minutes, but it was enough to really pique my interest and see where this would lead. I needed more strings and more power, which needed more power for more strings. And here we are 13 years later with the current prototype. In the early stages, I was just using off-the-shelf components to drive the vibrations in the strings, and I just burned out part after part after part, getting more and more expensive and more powerful, but just not having the power it needed to shake this many strings. The strings are under quite a lot of tension and they really don't want to move much, so it takes a lot of force to actually vibrate them enough to get the resonant effect going. So I was essentially forced to embark on a journey of learning about magnetic inductance, coil winding, impedances, heat dissipation, all these things to figure out how to make the driver myself actually work. This part here is the driver, and it's essentially a 100-watt loudspeaker, but it vibrates the clamp-on bridge instead of a speaker cone. In this prototype, it's all 3D printed grey plastic, which has been great for all the iterations and refining the design and coil specs, but the final product is being machined from aluminium for lightweight, rigidity, and heat conducting. I can use this current version fine, but I do need to keep an eye on the temperature, and that's not something you want in the final product. You want to be able to turn it up to 11 and so on. With so much energy being sent into these strings and so many strings at once, you might wonder why all the strings don't just vibrate in a cacophony of chaotic noise. And to a small extent that does happen, but because of the principle of sympathetic resonance, only strings that are in tune with or in harmony with the input signal are the ones that really resonate along. When there are frequencies in the amplified sound that match up to the tuning of the strings, those strings will resonate a lot more than the rest of the strings. So in this demonstration, you can see with this rope, as I'm shaking one end of it, the whole thing moves a little bit. As I increase the speed and get closer and closer to the fundamental frequency, you can see it start to resonate. As I speed up even more and go past the fundamental frequency, the rope movements become chaotic and more minimal again, until I get even faster and find the first harmonic, and now the rope is moving in two parts with a still part in the middle. This is essentially what's happening in the resonator. Strings that are in tune with the input signal are resonating a lot, and all the other strings are only moving a little bit. The problem is there's so many other strings, and some of them are just out of key and really adds a lot of chaos into the sound. So I developed this key selector mechanism to keep those strings under control. It lets you choose which strings can resonate and which strings are muted. As you turn the dial around, the levers rise and fall in a specific pattern that comes from the cycle of fifths. This means that you can go from, for example, the key of D minor to E flat major just by turning the dial without needing to retune any strings. And that brings us to tuning. The resonator has 36 strings, starting from C2 on the low side, going up for 3 octaves. The strings are guitar strings, going from 64 gauge all the way up to 8 gauge, and the scale length on the long side is based off a typical electric guitar, and then the scale length on the short side is based off a mandolin. The tuners are German-made Whitner string adjusters, repurposed from cello and viola. The pickups are lace alumitone noiseless pickups, and they're great because they don't hear any of the direct bleed coming from the driver coils. They're quite a broad spectrum pickup, which is great for this purpose. It's not something I would typically choose for a guitar purpose where I want something a bit warmer and brighter. But here they work really well and they respond really well to all kinds of signal processing afterwards too. The wooden part of the bridge assembly is based on a sitar buzz bridge and does a lot of work to bring out the upper harmonics and overtones in the notes and create a much more interesting and rich overall sound. It's mounted on a plate with some screws you can use to adjust its tilt, which controls how clean or buzzy the strings are. The bridge also has a damper, which is controlled by a foot pedal, so you can easily quiet the instrument without using your hands. All these metal parts are made from laser-cut stainless steel, which I polish and fold and drill and tap. In terms of the overall construction, the body of the instrument is made from several layers laminated together. On the bottom is 2 layers of structural plywood routed out for all the truss rods and wiring. Plywood's great because all the cross-grain laminations make it really stable. And then on top of that, there's a 20mm layer of hardwood for the main part of the body. And on top of that is 2 more 20mm hardwood blocks on the headstock and underneath the bridge. This adds to the overall rigidity of the instrument and gives the tuning pins and hardware a nice strong surface to fix to. The body is then surrounded by a hardwood frame, and in this prototype, the frame and body parts are all made from Tasmanian oak, which is a beautiful timber. There's also more options available like jarrah, mahogany, and maple and blackwood. When it comes to using the Resonator, there's one more piece of gear that you need, and that's an amplifier. I recommend using a roughly 100-watt stereo amp, like this studio foldback monitor, but in reality, any home stereo hi-fi amp will do the job just as well. I use this little mixer to go in front of the power amp so I can take audio from multiple channels and control the panning and EQ separately of all of those inputs. The Resonator is proper stereo with 2 inputs and 2 outputs, so you can send a different signal to the high and low register, or you can EQ them differently, and the EQ actually has quite a big effect on how the Resonator responds to the input sound. I have a whole section of the user manual dedicated to all the different gear that you can use for all the different setups, so check that out if you're interested. Once you have the Resonator hooked up to an amp, you need somewhere for the output to go. Because they're guitar pickups, they need a high impedance input to go to. So you can use a guitar amp or a DI box or an instrument line in on your recording interface. Once you've got it making sound, the next thing you need to do is tune up. This can be a bit of a pain, but once you get it down, it only takes about 10 minutes and it makes a big difference. Because like we talked about with the sympathetic resonance earlier, it needs to be quite closely in tune to the input signal to get that resonance really working well. When I tune up, I like to use a clip-on guitar tuner on the bridge to get in the ballpark and then tune by ear to the source sound that I'm using from there. I'll show you a small demo where I'm using the Resonator as an instrument in its own right. In this sense, the sound that I'm using to drive it won't be heard in the music, so I'm just crafting a sound to get the most resonance out of the instrument. And I found that works best with a very simple sine wave coming from a synth with a slightly slowed down attack time to reduce any percussive chaos that it brings into the system. In these next clips, the performers are playing in duo with the Resonator. It's being driven by a signal taken from a DI box or microphone on stage, and then everything is recorded live. This allows the performer to learn to anticipate the sound coming from the Resonator and essentially play the Resonator through their own instrument while they're performing. I'll leave you with these few clips of Genevieve on harp, Josh Hooke on piano, and then Louis King on guitar, and the full videos of their performances can all be seen on my channel. If you have any questions or comments, drop them below and I'll go back to you when I can. Thanks for watching.